Hello everyone, you are watching Learn with Lovejeet, and in this video I will be discussing dynamic memory allocation in C language. Basically we do the dynamic memory allocation in C using functions malloc and calloc. Now to use these functions we have to import this, we have to include this library stdlib.h, standard library.h. In this library the declaration for these functions malloc and calloc is there. Okay, now here on line 7 I have declared an array named ARR of size 7. Okay, and I have also initialized it with 7 elements. Now when we write a line like this, okay, what happens is the memory is allocated at compile time for 7 elements of int type. Okay, and this memory will be allocated on the stack. Now once this memory is defined, that is the memory for 7 elements is defined, we can decrease or increase this memory. For example, if I have declared here that memory is to be allocated for 7 elements, okay, and if I initialize it with now 4 elements only, okay, now 3 space for 3 elements integer type elements is empty. Okay, so I cannot decrease the size, or if I need to declare, if I need to initialize with this array ARR with 11 elements, okay, that is also not possible. I cannot increase the size at runtime for this array declared at compile time. Okay, the memory is basically given to this array at compile time. So increasing or decreasing the size of this memory is not in the hand of the user. Now to basically avoid this things like this and to declare the size at runtime, we can use functions malloc and calloc. So here on line 9 I have declared a pointer variable of integer type ptr and also two variables of size and x of integer type. Okay, now on line 13 I am basically simply printing the message enter number of elements to the user, and using this scanf function I have given the argument as address of size. So whatever value the user enters using the keyboard, that will be stored at the address pointed by size. Okay, then here I am basically printing the value entered by the user. Okay, now this is the syntax. Here I have used declared this malloc function, and inside the parenthesis size variable, but size variable give me the value that the user enters, okay, into size of int. So if I need memory for 10 elements, okay, so here I will enter 10 and 10 into size of int, let it be 4 bytes, so 10 into 4 40 bytes, so 40 bytes will be allocated to okay using malloc. Okay, now this malloc function, if the memory is not allocated, it will return null to the system, okay, to the system environment. And if memory is allocated, it will return a pointer of void star, okay, of type void star. That is, the pointer doesn't have any type like int, char, float, double, etc. So we need to typecast that to the appropriate type. Here I am basically storing integer type variables. Okay, I will be storing integer type information in that memory that is allocated. Okay, so I will typecast this memory, okay, the pointer to this memory with int star, so that the compiler knows that we are pointing to integer type memory. Okay, we are basically going to access information of integer type. Okay, now we have typecasted here this, and this pointer, okay, is assigned basically to another pointer that I have declared above, ptr. So now this basically malloc, here malloc, inside this I've used size, let size be 10 into size of int 40 bytes. So using this malloc, okay, 40 bytes are allocated at runtime, that is at it is done dynamically, and then it returns a void star pointer if the memory allocation is successful, otherwise it will return null. Now assuming that it was successful, okay, now I have typecasted, okay, this to integer type, integer star, okay. Basically malloc returns a pointer of void star to the memory allocated, and I have typecasted that to int star, and then I have assigned basically to another variable, pointer variable ptr, okay, basically, okay. Now here also malloc basically allocates single block, okay, so 10 into 4 40 bytes, a single block of 40 bytes will be allocated. This is important, single block of 40 bytes. Now here I am comparing if ptr equal to null, that is if the memory allocation was unsuccessful. So what malloc will return? Malloc will return null. So this null will be assigned to ptr. Now if ptr is equal to null, that means memory is not allocated and exit the this program. Otherwise, if memory allocation is successful, okay, so if memory allocation is successful, then what I am doing, I am using this for loop from 0 to size. If the size was for 11 elements, okay, so here I am basically initializing this 11 elements with some value x plus 1. So when x is 0, the element at that address will be initialized with value 0 plus 1 1, okay. This is how it runs, okay. Now I will show here. Let, okay, let the size be, I have entered the number of elements to be 3, okay, and now 3 into 4 12 bytes, okay, 12 bytes are allocated, and this 12 bytes pointed to that 12 bytes is returned to ptr, okay. Now I have allocated this memory to hold integer type information, okay, and let the base address be 1000, okay, so 1000, and memory will be allocated till 1011 bytes, okay, 12 bytes, okay, so 1000 to 1011. Now when I try to do this 1000 plus 1, it will point to 1004, okay, because integer is of 4 bytes, and when pointer is incremented it will point to the next element of information of its own type. So at 1000 I am pointing to integer, and 1000 plus 1 it will point to the next information of its type of integer type. So next type of so next information is present at 1004, next at 1008, and next at 1012, okay, sorry, first is present at 1000, then 1004, okay, 1000, 1001, 1 2 3, then 4 5 6 7, then 8 9 10 11, then 11 12 13 14. Here I am basically allocating 12 bytes. So first element will be present at 1000, 1001, 1002, 1003, okay. These 4 bytes basically are basically taken to store first integer, okay. Then from 1004 to 1007 second element, then 1008 to 1011 third element, and when I write 1000 plus 1, it will point to the next memory location that holds next piece of integer type information, okay. Now here what I am doing, I am basically doing this ptr plus x equal to x plus 1. Now here ptr plus x, what is ptr? Ptr is 1000, 1000 plus 0 remains 1000. Now change the value at this address with x plus 1, that is 1. So what will be at 1000? It will be 1. Now next time x equal to 1. Okay, now ptr plus 1, ptr plus 1, that is 1000 plus 1 is equal to 1000 plus 1004. At 1004 what I am storing? 2. Now next time x will be 3, x will be 2, so ptr plus 2, ptr plus 2, ptr plus 1, ptr plus 2, 1008. At 1008 what I am storing? 2 plus 1, 3. So at 1008 what will be stored? 3. And then I am printing these values using this printf function. So let's see what is printed here. If I give 3, so what is printed? 1, 2, 3. Okay. Now let me explain this again. So first, here array was declared, okay, that memory was given at compile time. So what was the drawbacks? Basically, I am basically, if the size is like 7, okay, and I am storing number of elements as 3 elements on, I'm sure, okay, so storage of wastage is for 4 elements, okay. So when memory is allocated a compile time, I am not allowed to decrease or increase the memory. Okay, memory once allocated remains there. The compiler is the one that may be freeing that memory. Okay, in future. Okay. Also, that is here. See, I have no control. No control. You don't have any control on memory allocation and deallocation. The C compiler controls memory allocation and deallocation. You can clear allocated bytes from memory if you don't require at any stage. So to counter this, what I use? I have used malloc function. That is, I am allocating the memory at runtime. This is dynamic memory allocation. Inside this malloc function, what is the argument I am giving? Size into size of int. Size basically here is number of elements into size of int, that is 4. So let the size number of elements that I need to allocate memory to is 3. So 3 into 4, 12. So 12 bytes are allocated, and pointer of void star is returned to that memory portion allocated. Okay, then we need to typecast that to the type of information we will be referring to. So as I am storing integer type information there, so I have typecasted this void star pointer to int star, and then I have allocated this to assign this to pointer ptr of integer type. Now here inside this if statement, I am comparing if it is equal to null or not null. If it is equal to null, then that means the memory was not allocated, it was unsuccessful, and exit the program using this exit function. Otherwise, if the memory was allocation was successful, basically I am assigning the elements. At 1000, I have assigned 1 at 1004, 2 at 1008, 3. And using this for loop, I am basically printing the elements. So malloc the summary about malloc is single block of memory is allocated and void star pointer of void star is returned to the allocated portion of memory. Okay, also the memory is uninitialized. That means, okay, here I have assigned memory for 12 bytes. Okay, first byte is from 1000 to 1003, then 1004 to 1007, 1008 to 1011. Okay, before this for loop starts, here basically I am assigning the values at this 1000, 1004, 1008. Okay, okay, before this initialization, if I try to print this pointer star, okay, if I try to print the value at 1000, what will be printed? Garbage value. Okay, so the memory is uninitialized. Okay, it contains garbage value before initialization. So this was about malloc function. Now next is calloc function. The functionality is same. Okay, it is also used for dynamic memory allocation. However, the syntax is little say different. Here there are two parameters. The first one is num and the second is size of int. So first one is num, basically for how many elements I need to give the allocate the memory at runtime. So this will be num, let it be 3. Then size of int, okay, what type of information I will be storing there. Okay, then according to that I will be requesting for the size. So 3, and here size of int will be 4. Okay, now in case of malloc, a single block of memory was allocated. When I requested memory for 3 elements, a single block of 12 bytes was allocated. Here it is little different. When I am when I'm requesting memory for 3 elements, okay, so 3 blocks of 4 bytes each will be allocated, and then a pointer will be returned to the first block. Okay, and then this is assigned to PTR. Now PTR refers to the first block of memory allocated. Okay, this is clear. Okay, in case of malloc, a single block is allocated. In case of calloc, number of blocks are allocated of same size. Also, as opposed to malloc, where the memory blocks allocated were uninitialized, that is, they contained garbage values. In case of calloc, the memory blocks are initialized with value 0. Okay, so here, see 0. Okay, let PTR. Okay, here, basically I have given here, I'm not getting the input from the user. I have given it in the program itself. So I am basically requesting memory for 3 elements. Okay, then 3 blocks of 4 bytes each will be allocated, and a pointer of int star will be returned. Okay, I have typecasted it to int star. Then PTR will be referring to that memory. Okay, the first block is as 1000, second block at 1004, third is at 1008. Now, if I try to print the value at 1000, PTR basically points to base address. Okay, at base address, what is base address? 1000. Value at 1000 will be 0 because the information is initialized to 0. Okay, so this will print 0 in case memory is allocated. Otherwise, this message will be printed. Now, here this is same as before. Okay, this was calloc, this is malloc. Okay, this thing is same. I am basically initializing the memory using other values. Okay, so same 1 2 3. So clear? This was about malloc and calloc function. These functions are basically used for dynamic memory allocation in C language. So in my next video, I will be discussing topics related to dangling pointer, memory leak, and free function. The free function is basically used to free the memory, unused memory at runtime. So keep watching, learn with lovejeet.